My name is Cheyenne Powell, and I'll be reporting this morning for Holmes Middle School News. Today I'll be discussing our atmosphere with the help of some YouTube videos. The title of our first video is Aviation, Meteorology, Basic Structure of the Earth's Lower Atmospheric Layers. What I learned was that the Earth's atmosphere is really simple. There are multiple layers. Together, they end 350 miles away or more from the Earth. Now we're going to see if you can learn from the video like I did.
Hello, I'm going to talk about the structure of the atmosphere for meteorology. The basic structure of the Earth's atmosphere is actually quite simple. There are multiple layers rising above the Earth's atmosphere, and I'll only be covering two layers located closest to the Earth's surface. That's the troposphere and the stratosphere. The troposphere is the part of the Earth's atmosphere we are most familiar with. It contains the air we breathe. Generally speaking, as far as the troposphere is concerned, the most dense air particles are found closest to the Earth's surface. Also, as you climb further away from the Earth's surface, not only does the air density decrease, but the air temperature also decreases with altitude. This explains why we get snow in the mountains. It's colder on top of the mountain than it is at sea level. To sum up the troposphere, generally speaking, the air is more dense closer to the Earth's surface, therefore a higher air pressure. And as you climb higher away from the Earth's surface, the air density decreases. Therefore, the air pressure decreases. Temperature of the air also decreases with any gain in altitude. The height of the troposphere differs in different parts of the Earth. The troposphere is highest over the equatorial region and lowest over the North and South poles. The troposphere is usually as high as 60,000 feet over the equator and as low as 20,000 feet over the poles, as shown in this graphic. These are not exact heights, they're only estimates. The tropopause is the boundary layer separating the troposphere with the next layer above it, the stratosphere. Now, the main distinguishing feature of the tropopause is any gain in altitude, the temperature actually remains the same. The temperature does not get any colder with any gain in altitude, unlike in the troposphere. The constant temperature with gain in altitude is called an isotherm. The tropopause represents where the isotherm begins. The stratosphere is the layer above the troposphere. The lower part of the stratosphere, as you now know, maintains a constant temperature with any gain in altitude. However, this does not remain throughout the whole layer of the stratosphere. In the stratosphere layer, it eventually reaches a point where any gain in altitude actually increases the air temperature. So the lower part of the stratosphere starts off maintaining the same air temperature with any gain in altitude and eventually gets warmer with any gain in altitude. That's almost the opposite of what we're used to in the troposphere. There's no need to go into any details as to why this is the case, but it's important to understand the basics of both of those atmospheric structures. And that covers the basic atmospheric structure around the Earth.
Since the troposphere was mentioned in the previous video, our second will be troposphere video learning. I learned, among many things, that the depth of the troposphere is 17 kilometers of the middle latitudes. I learned the lowest portion contains 75% of the atmosphere's mass and 99% of water vapor and aerosols. Here, take a look for yourself.
The troposphere is the lowest portion of Earth's atmosphere. It contains approximately 75% of the atmosphere's mass and 99% of its water vapor and aerosols. The average depth of the troposphere is approximately 17 kilometers in the middle latitudes. It is deeper in the tropics, up to 20 kilometers, and shallower near the polar regions, approximately 7 kilometers in winter. The lowest part of the troposphere, where friction with the Earth's surface influences airflow, is the planetary boundary layer. This layer is typically a few hundred meters to 2 kilometers deep depending on the landform and time of day. The border between the troposphere and stratosphere, called the tropopause, is a temperature inversion. The word troposphere derives from the for change, reflecting the fact that turbulent mixing plays an important role in the troposphere's structure and behavior. Most of the phenomena we associate with day-to-day weather occur in the troposphere. The chemical composition of the troposphere is essentially uniform, with the notable exception of water vapor. The source of water vapor is at the surface through the processes of evaporation and transpiration. Furthermore, the temperature of the troposphere decreases with height, and saturation vapor pressure decreases strongly as temperature drops, so the amount of water vapor that can exist in the atmosphere decreases strongly with height. Thus, the proportion of water vapor is normally greatest near the surface and decreases with height. Thank you for watching. For more educational videos, please subscribe to WizScience on YouTube or visit wizscience.com.
My last two videos are the most important because they introduce how pollution could affect our environment as well as our future. I'm starting with cloud-covered documentary. Because this video is just shy of an hour, I've pulled just a few parts for you to watch. Like our narrator tells us, the sky provides the reassurance that all is right with the world. Our Earth is taken for granted.
For most people, a clear blue sky is a comforting sight. Indeed, of all the familiar sights in our life, the sky provides the reassurance that all is right with the world. But as with all things with which we grow comfortable, we sometimes take the sky for granted. Here is your sky, clear, blue, and limitless. Here is another view of your sky, this time dotted with clouds.
What is the difference between man-made clouds and real clouds?
This kind of airplane trail, and these trails. Obviously, these easily observable trails are not natural cloud formations. They can be seen on any given day to come from airplanes. They are man-made and dissipate rapidly in the sky. These too are man-made and come from planes. But these trails linger, collect, and eventually cover the entire sky. Is there any difference between these clouds and these clouds? Between these trails and these trails? Why haven't we noticed them before? And why isn't anybody talking about them?
This topic should be taken seriously by more people. What are contrails?
What you are seeing now is quite normal. These temporary trails are called contrails, which is a word formed from the words condensation and trails. They are made of water vapor, and they are a common and natural occurrence, which happens as a result of aircraft flying at high altitudes, in particular ordinary weather conditions. You can see that the condensation disappears fairly quickly, much like your breath on a cold winter day.
What are clouds?
For a normal cloud to materialize, two fundamental elements must exist: particles such as microscopic dust and moisture. Unlike contrails, clouds cannot form well in especially clean air. They require particles that act as a base for water vapor to cling to. The size of these particles must be extremely small, less than 1/100th of the width of a human hair. The other essential component for normal cloud formation is a humidity level of about 70% or more. Notice that the requirements for cloud formation and contrail formation are entirely different from one another. Clouds need moisture and fine particles for the moisture to cling to, and contrails need the opposite: clean, dry air. This is because they are based upon entirely different natural laws.
Now I'm going to introduce our last helpful video, Aerosol Crimes First Edition. This video is almost 2 hours long, so let's just say it taught me a lot.
Please remember the world that you are now seeing, for this natural world is in jeopardy, and even if you are willing to help put an end to what you are about to see, you may never be able to see the world in the same way again. In the early part of 1999, an immense operation began, an operation using aircraft that many of us will find difficult to accept. This operation involves a dispersal of massive amounts of fine materials into the atmosphere, and the implications of these actions are grave and far-reaching, and they strain the limits of understanding. There will be counterclaims to the evidence that is presented within this film, and you will be told that all is normal and as it should be.
Watch more and make your own conclusions. Well,
what you are seeing now is quite normal. These contrails are the trademark of high-altitude aircraft since the close of World War II. You notice that the condensation disappears fairly quickly, much like your breath on a cold winter day. This is as it should be, and as it has been. For those curious enough to delve into the physics, chemistry, and thermodynamics of contrails, this normalcy has a more thorough explanation. Yes, science and common sense do agree, and the balances of nature are achieved with this common phenomenon.
I'm going to show you this interview to end our report.
Alice Merklin's Mysteries of the Mind. It is the world that has been pulled over our eyes.
As you know, I've been a pilot for over 40 years. I've been flying. I stopped counting my hours at 3,500 hours, which is a fair amount. I've owned 7 airplanes in my life. I have ratings all the way up to twin IFR. I am not jet rated, but you know, everything else. But today, Clifford, when all of a sudden you see these trails in the sky in the morning when you wake up, and by late morning, early afternoon, the sky is totally overcast. It is not natural. The government and other people say, oh, well, that's a contrail, condensation, contrail that all planes do at a certain altitude. And I said, you don't know what you're talking about. Yes, there are contrails. Go back to World War II, we had contrails, but they didn't last. This was, in those days it was condensation of moisture, and then it dissipates after, I don't know, maybe depending on the altitude, maybe a minute, maybe a little over a minute, but around a minute, and it's gone. These things last all day long, unless there's a strong wind and it blows out of the way. Now it's gotten so bad, and I talk to people, as you know, all over the world, and it's happening almost every country that I'm aware of in the world. We have listeners in at least 50 countries that we know of, and people are always reporting back. If we get into a discussion or times that you have been on the show before, people come back and just report incredible experiences. They have a lot of respiratory problems. They never had that before. People are having a lot of sinus problems. They've never had that before. And it's always after they have been inundated with some of these sprays. You also asked about, how do people feel about it? They are extremely concerned because there seems to be something that is happening that is affecting them physically and in some cases even emotionally and psychologically. So there is a drastic change in what is happening around us in 5 years, 5.5 years, and people have never seen this or experienced this before.
Well, I hope you learned as much as I did. For fun, my mom is going to rap a song I came up with.
There are very few molecules left up here, so the first is the troposphere. We live in it, all of us. It's the reason we have weather on our planet, trust. Bored is probably how you feel, but there's no need to fear, 'cause next up is the stratosphere. Planes fly through, the air's thin, less fuel, more dough. But we're still going up from here, because next on the list is the mesosphere. The third layer in our atmosphere. The thermosphere, it's the last layer amazingly. It measures over 90 kilometers crazily. One more thing I need to say, that unknown ionosphere helps us communicate. The radio waves from Earth bounce off of that big blue and silver thing that looks like a trough. Word.